Okay, starting off the second lesson, we're working with exponents and radicals. For the first problem, there's a number of things you could do depending on what properties you apply first or which properties you apply. So this is something that we could do. We can make all these exponents positive by switching their positions. Alrighty, after that, we can cancel out one of the 3's up here with one of the 3's on the bottom. Or in other words, you're just subtracting the exponents. You could do that as well. And then we have 4 times 4 over 3 equals 16 over 3. I want to show you some different ways to go over this type of problem. We could have subtracted the exponents, like I mentioned earlier, 1 minus 2, because we're just applying the quotient rule. And we have 4 times 3 to the negative 1 power times 2 to the second. And we want to make that exponent positive, so we'll bring it down to the bottom. And then we'll still end up with the same result that we have to the left. And there's more ways to do this problem than just the 2 that I showed you. For part B, any number raised to the 0th power is equal to 1. On to the next example. Evaluate the expression for the given value of x. So evaluate means you're just plugging the value in that they give you for x. So we have 7 times 4 to the negative 2nd power. Okay, now this piece is raised to the negative 2 power. So that's what you're bringing down to the denominator position, not the whole thing. So we have 7 over 4 to the 2nd power equals 7 over 16. Done. Next example. Simplify the expression. Okay, so there's a number of different ways to do this problem. I'll show you the very basic way. If you don't know any of the properties, you could just expand each exponent as such and just cancel out one of the numerators with one of the denominators. So your answer is not r squared, it's 1 over r squared. Be careful with that. You could have just as well applied the quotient property. So you would have r to the 4th minus 6 equals r to the negative 2 power, which is 1 over r squared. So your choice how you want to do it. It's naturally more efficient if you know the properties. Okay, for this problem here, we will apply the exponent to both the numerator and the denominator, and we'll end up with this. 4 times 4 times 4. Then we have times 3 times 3 times 3 times 3. On the bottom we have y times y times y. Then we have y times y times y times y. Okay, so if you multiply all these values, we get 5,184 over y to the 7th power. You could have just as well kept this as y to the 3rd and kept this part as y to the 4th. And when you multiply them, you get y to the 3rd plus 4 equals y to the 7th. On to the next example. Rewrite each expression with positive exponents and simplify. Okay, so we're going to do 4 times 8, which is 32. Then we have y to the negative 2nd, and we're going to apply the product property here of exponents. So we're going to add up the powers. So we get 32 times y to the 2nd power. Next example. we're going to distribute this exponent to the exponent of all the values. So we have x to the 9th power, and y to the negative 12th power, and 5 to the negative 3 power. All right, the last thing you want to do is make your exponents positive. So we'll have 5 to the 3rd on top, times x to the 9th, and y to the 12th on the bottom. Alrighty. Okay, we're going to evaluate each expression without using a calculator. Now here's a simple example to develop a better understanding of what we're doing in these problems. I'm just going to rewrite 100 as 10 squared. Now we already know that the answer is 10. Right? Square root of 100 is 10. But understand this relationship. You just take the exponent and you cut it in half because this is the square root. All right, so we get 10 to the first, or just 10. So for part A, we're going to take this expression and break it up into two parts using the product property for radicals. Now I know the square root of 25 is 5. Now what's the square root of 10 to the 8th? Well, going back to what we did here, we know that we just take the exponent and we cut it in half. So it's 10 to the 4th. And then this just means I'm going to add on 4 zeros. So I end up with 50,000. All right, let's do it one more time with part B. Now be careful in this problem, we're working with the cube root. Watch out for that. So I have the cube root of 8 times the cube root of 10 to the 15 power. Okay, now the cube root of 8. What number times itself is 8? That would be 2. All right, now what are we going to do for this next portion here? Well, for the square root, we cut the exponent in half, or we divide it by 2. In this case, since we're working with the cube root, we're just going to take 15 and divide it by 3, which gives us 10 to the 5th. So adding on 5 zeros, we get 200,000. That's all there is to it. Done. On to the next example. Now we're going to evaluate each expression here without using a calculator. Whenever you have fractions that are exponents, that means you're working with a radical, and the root of the radical is whatever the denominator is for the fraction. And the numerator is simply the power of the number inside the radical. So we have the cube root of 27, and that's really simple. That's just 3. Or if you want to use the prime factor tree, 3 goes into 27 9 times, 3 goes into 9 3 times, and we're looking for a group of 3, which is what we have here, and we use the number 3. So there's your answer. Now for 36 to the 3/2 power, we have 36. We're using the square root since the denominator is 2, and we're raising 36 to the 3rd power. Now you could take 36 and you can multiply it by itself twice, or you could do this. All right, now applying the product property for radicals, I have this, which makes the problem much easier to simplify. So square root of 36 is 6 times 6 times 6. And 6 times 6 times 6, a good one to remember, is 216. That's all there is to it. Now go ahead and begin your assignment on the bottom of the web page.